morning, students. Welcome to the Science 1 class. Today we are going to learn about distance, displacement, speed, velocity, and uniform and non-uniform motion. Let's see one by one. Let's take a look at these terms first. Consider this example. Let's say this is the view from the top and your house is here and your friend's house is at the other end of the park. There is a road all along the park. Now let's say you travel to your friend's house like this. So along this road and then along this road. So what is the total distance traveled by you? It's going to be this distance plus this distance. How will you practically measure it? You can use a measuring tape. But you need a really long one. Now let's say this length is 40 meter. This length is 30 meter. So what is the total distance traveled? It's going to be 70 meters. So what is distance? Distance is defined as the total length of the path traveled. How do we calculate your displacement? Displacement is defined as the shortest distance from the initial to the final position. Your initial position is your house and the final position your friend's house. So what is the shortest distance? It's going to be a straight line from the initial to final. How do you calculate the displacement again? You can use a long measuring tape, or can you see the right angle triangle here? We can apply Pythagoras theorem because the displacement is the hypotenuse of right angle triangle here. So the displacement is going to be the square root of 30 square plus 40. So that 50 meters. And as you can see, it's less than the distance now. Let's say there's a curved path along the park, something like this. And you walk to your friend's house along the curved path. What is your distance and displacement in this case? Displacement is easy because it is the shortest from your initial to the final position. So it's going to be 50 meter again. But how do you calculate your distance? How are you going to practically measure it? And it should be accurate. So one thing you can do, you can take the help of rope. So if you place a rope along that curved path as you walk, and then you need to measure the length of the rope, that will give you the distance. There's one more important difference between the distance and displacement. Distance is a scalar quantity while displacement is a vector quantity. Now what do these terms mean? Scalar means it has only magnitude. So only a value but no direction. And vector quantity means it has both magnitude and direction. So let's look at our example. Here, when you travel your friend's house like this, distance was 70 meters, but there's no direction specified. But if you look at displacement, our displacement has a value of 50 meters. Now what is the initial direction from the final position? So if this is north in the map, our direction is going to be northeast. So your displacement will be 50 meter in the northeast direction. Let's put distance and displacement in our concept board. Now let's talk about speed. Is defined as the rate of change of distance. Whenever you see this word rate, it means divided by time. So the formula of speed is distance by time. Now let's look at our example. The distance we had traveled was 70 meters. Now let's say you took 1 minute 40 seconds to reach your friend's house. So how many seconds is that? That's right, 100 seconds. Now let's play the value and calculate your speed. So speed is going to be 70 meters by 100 seconds. So that 0.7 meter per second. So that's the SI unit of speed because it's distance by time. So the unit is meter per second. Now let's talk about velocity. Velocity is defined as the rate of change of displacement. So similar to speed, the formula is going to be displacement by time. Now let's look again at example. So our displacement was 50 meter and the time is the same, 1 minute 40 seconds. So what is your velocity? That's right, 50 meters by 100 second, so that 0.5 meter per second. So speed and velocity have the same unit, meter per second. So just like distance and displacement was scalar vector pairs. So speed and velocity, and it's easy to remember, S for speed for scalar, V for velocity, V for vector. Let's go back to our example. The speed we found it was 0.09, but that's no sense of direction because it's a scalar quantity. And what's the velocity? That's right, 0.5 meter per second. So what is the direction of the velocity? It's along northeast direction. So the complete answer of velocity will be 0.5 meter second northeast because it's a vector quantity. Now let's say come back from your friend house using this path, but this time you didn't walk, you borrowed your friend's bicycle and came back really fast, let's say in 40 seconds. So let's discuss the physics terms here. What is the total distance traveled by your entire journey? That is from your house to your friend's place and back. So the total distance is going to be the perimeter of the rectangle. So that 40, 30 and 40 plus 30 meter. So that's total of 140 meters. That is the total distance traveled by you. Now what is your displacement? So your initial position was your house and that's also your friend final position because you are back here. So what is the shortest distance from the initial to the final position? That's right, your total displacement is 0 because you are back at your home. Now let's talk about speed. But since our speed is changing, once we walking and the other time you are riding your bike, so it makes more sense to talk about average speed. Now speed is distance by time, so average speed is total distance by total time. And what is the total distance? Distance here is 140 meters. And what's the total time? It was 100 seconds and 0 seconds and 40 seconds. So your average speed is going to work out to be 1 meter per second. Now let's look at average velocity. So similarly, it has a formula of total displacement by total time, but the total displacement is here 0. So that's right, your average velocity is 0 meter per second. Let's put a speed and velocity on your concept board. Now let's talk about uniform and non-uniform motion. A body is said to be in uniform motion if it's traveling equal distance in equal interval of time and in a straight line. Let's break down this definition. The first part says equal distance in equal interval of time. For example, let's say a car is traveling 10 meters every second. So the car is going at a constant speed of 10 meter per second. And the second part says it needs to be traveling in a straight line. So the direction is constant. So here we have constant speed and constant direction. And we know that velocity is speed with direction. So the car is basically moving at constant velocity. And a uniform motion means a body is traveling at constant velocity. Non-uniform motion is exactly the opposite of uniform motion. So does that mean it is unequal distance in unequal intervals of time? That's going to be really confusing. So that interval need to be kept same. So non-uniform motion means a body is traveling unequal distance in equal intervals of time. Let's take an example. A car is traveling 5 meters in the first seconds, 10 meters in the second, 7 meters in the third second. So can you see that the distance is traveled every second or unequal here. So the speed is changing, and in non-uniform motion the speed is not constant. Let's play uniform motion and non-uniform motion on concept board. That's all for today class. Thank you students. Have a good day.